Hello, everybody, and welcome to today's webinar, Introduction to Static Analysis. For those of you who don't know us yet, BUGSENG specializes in software verification tools and services with a strong focus on safety and security critical systems. We work closely with organizations in the automotive, industrial, aerospace, and other regulated sectors to help ensure their software meets the highest quality standards. This is the first webinar in a new series that we called Software Verification Done Right, which is inspired by this little book that you see here on the screen, which was published by BUGSENG back in February this year. Like the book, the series will take us through several chapters, each dedicated to a key aspect of static analysis and software verification. Basically, the goal of this webinar series is to give you a solid foundation to navigate the current and the upcoming software regulatory landscape with confidence, and also to prepare you for safety and cybersecurity audits. To add a little twist, we'll be bringing guest speakers from across the industry, which is exciting. Our guests will share insights and experience on a selection of topics. And today we will actually take a look together at all these topics, so you have a good overview of what's coming in the next sessions. And yeah, with that, let me say hi to our speaker, Roberto Bagnara, which is Professor of Computer Science, Software Verification and Functional Safety expert, as well as co-founder of our BUGSENG. Roberto is also the main author of the book and will be our guide for this entire series. Welcome, Roberto.
Hello, welcome. Thank you.
Thank you. Roberto, can we start with a couple of questions? Do you mind?
Sure, go ahead.
Okay. So tell us, what's going on with this new regulations, the CRA, for example?
Okay, so the CRA is a big topic. It's a Cyber Resiliency Act, and it requires secure by design for all products with digital elements that are sold in Europe. Doesn't really matter where they are produced. If they have to be sold in Europe, they have to be secure by design. And today, products with digital elements, meaning that they contain some hardware or software, and typically both, means basically a whole lot of products. And the CRA has severe penalties for non-compliance, and this is quite a challenge for organizations, because they need to embrace a new model. They need to prove that the products are built right from the start, and also they need an ability to update them quickly and safely whenever cybersecurity threats emerge. And for safety relevant products, the thing is particularly challenging. In traditionally safety related development, you typically do not change the software unless you are really forced to. So, okay, there have been very famous recalls of cars, for example, due to defects in the software. But now, any newly discovered vulnerability would require car makers and product manufacturers in general to take immediate action, and so to update the software in the product. And given that for safety relevant products, you have to maintain not just security, but also safety, this means that having to update quickly the software, you have to repeat all the safety verification many times. And this means that we need a lot of efficiency in in safety assurance. So that's why static analysis and continuous integration are even more important. And we need to be fast, efficient, secure, and safe. And so this is why we have the book, basically. So we insist a lot on static analysis, of course, but also on continuous integration and on efficiency.
Of course. But how much time do we have exactly?
Not much. So the first part of CRA will enter into force in 2026, but the very important part will be in force on December 11, 2027. And by that time, the thing I've mentioned before have to be in place. And I say that we don't have much time, because if a product has to be sold in 2027, development has already started, possibly, or it will have to start very, very soon. So yeah, we are in a hurry.
Right. And how do we get ready exactly for that, to be on time?
The first thing that we need to do, and possibly now, is starting due diligence. So this means that for every product containing digital elements, we have to conduct a risk analysis and of the product itself and of all its dependencies, taking into account the product's environment. So the result of that analysis will dictate what has to do next. Okay. In some, I think, not very common cases, the risk analysis will say there is no risk for security for this product. But in many cases, you will have to do something. So for what concerns our series of webinars, whenever the analysis indicates that the product security is dependent on code correctness, on the correctness of the software, then we need to have in place many of the things that in safety related development are already used since many, many years. So we need requirements, we need coding standards, static analysis, architectural constraints, qualification of tools and third-party libraries and components. And moreover, we need to do that in a continuous integration framework. This is not a requirement of the CRA itself. It's just because we need efficiency.
Clear. Thank you, Roberto. Now, please tell us more about this book and the webinar series that we start today.
Yes, sure. Thanks, Lavinia. So, Software Verification Done Right, Introduction to Static Analysis, is a small booklet me and other people at BUGSENG wrote and presented this year at Embedded World. The basic idea was to distill an extensive experience we have in software verification and static analysis in a small publication aimed at embedded software professionals. The result is an 80-page booklet divided in 8 chapters of manageable size. And by this I mean that every chapter can be digested in, say, less than 15 minutes. The book was presented at the Embedded World 2025 conference, and it was very well received. Now what we want to do is to further disseminate the book and base a series of webinars on its contents. We will have a webinar for each one of the chapters of the book. This webinar, which we might call Webinar 0, introduces the series by anticipating the contents of each episode. In the sequel, whenever I say Chapter 5, for example, I mean Chapter 5 and Webinar 5 as well, because there is a one-to-one correspondence between the chapters of the book and the webinars. Chapter 1 of the book and Webinar 1 of the series is about code quality and software verification. Everybody knows that software has a growing impact on our lives, as it is embedded in cars, medical devices, all sorts of devices that are critical for our lives, also from safety and security considerations. The consequences of failures of these devices are quite severe, as several cases from the past, but in the book you will see that there are cases developing right now, so it's not that the problem is solved already. So the consequences of such failures, they are very important, and indeed they bring to costly recalls, liability for the manufacturers, brand damage, and so on. The key message is that verification is an investment and not a luxury. So in webinar 1 and chapter 1, we go through the main attributes of high quality code: reliability, maintainability, readability, testability, efficiency, and so on. And on the techniques and methodologies that industry has distilled as the appropriate ones to achieve this quality. So code reviews, static analysis, dynamic analysis, and robust processes. So it is important to understand that this is not just a burden, it has a very important return of investment. It reduces technical debt, and by doing so, it saves resources over the entire product life cycle. Things are even more interesting when we consider that, in view of functional safety standards, cybersecurity standards, and new regulations such as the European Cyber Resiliency Act, many of these activities become actually compulsory. And our guest in webinar number 1 will help us decode the new situation. Chapter 2 and Webinar 2 introduce the MISRA C and MISRA C++ coding standards. While C and C++ have many advantages, in particular they are very efficient, there are lots of tools, lot of compilers, they run on every architecture, they also have downsides. They have many undefined, unspecified, and implementation-defined behaviors. The solution identified by industry is called language subsetting. Rather than programming in unrestricted C and C++, we code in a subset of those languages. And MISRA C and MISRA C++, they are the most authoritative coding standards for C and C++. They have been used over many years in all industry sectors. They are composed by a set of guidelines with different categories: mandatory, required, and advisory, that we will see in the webinar. An important thing in MISRA is the deviation process. The point is not that you shouldn't do this, no matter what. The point is code quality. So the ratio is comply when you can and deviate when you must. The thing is particularly important when safety and security are at stakes. Adopting the MISRA C and MISRA C++ coding standards results in more predictable and analyzable code. Here we see some example of the MISRA C coding guidelines. They are taken from MISRA C 2025, the very latest version of the standard. Directive 1.1 says that we have to document the implementation-defined behaviors we depend upon. The fact is that C has around 120 implementation-defined behaviors, and knowing how they are resolved in the tool chain we are using is, of course, a crucial ingredient to know what we are programming. Rule 1.1 and Directive 1.2, they say to stick to the standard version of the language, avoiding extensions as much as possible. Rule 9.1 is to rule out a very important source of undefined behavior, which takes place when we read automatic variables that are not initialized. Rule 7.4 also has to do with undefined behavior. In fact, reading a string literal is of course fine, but trying to write to a string literal is undefined behavior. So Rule 7.4 says treat every string literal as if it was const. Rule 14.4 has to do with type safety, and it insists, for example, that the guards used in conditionals and iteration constructs are essentially Boolean. The takeaway is that adhering to MISRA C and MISRA C++ helps systematically avoiding common C and C++ pitfalls. In Chapter 3 and Webinar 3, we talk about coding style and software quality metrics. The adoption of a coding style and the adoption of software quality metrics is complementary to the adoption of the MISRA coding standards. And in fact, coding style and software quality metrics are recommended by the most important functional safety and cybersecurity standards, as well as by the MISRA coding standards. So the point about consistency in the programming style is that it improves readability, and by doing so, it improves maintainability and improves the quality and efficiency of teamwork. We recommend the adoption of the stylistic part of BUGSENG 2018. It contains around 80 style guidelines for all aspects of the source code, and it has been designed from the outset to be compatible with the MISRA-C coding standard. It is suitable for automatic enforcement, and in fact, the Eclair software verification platform can check and auto-format code to unify the style at the beginning, and the outcome is that by doing so, it reduces friction in the team and reduces confusion in the code base. Software quality metrics are objective measures that provide quantitative data on the complexity, size, and coupling of program entities. It is very important, especially for project managers, in order to monitor the project and what's going on without having to look at every single patch. There are different software quality metrics. Some of them are very simple. For example, lines of code per function. We, of course, don't want functions that are too long because they are difficult to reason about, difficult to modify, and so on. We have complexity metrics like cyclomatic complexity and the more advanced N path and AC path. They have both to do with code readability, because if the code contains intricate control structures, then it is very difficult to understand. And also it has to do with testability. In the end, we have to test our code, and if it is too much convoluted, then providing a full set of unit tests will be very challenging, if not impossible. Another set of metrics has to do with function coupling, and there are metrics that limit the depth of the control structure nesting, and so on. The usage of software quality metrics is to identify hotspots in the code. So places in the code that, due to their complexity, they are in need of more review and or more testing. The thing is particularly important when software quality metric checking happens in continuous integration, because this way the entire team can immediately be warned when something is phishing. Chapter 4 and Webinar 4 have to do with requirements management and specifications. As the adagio says, without a specification, a system cannot be right or wrong, it can only be surprising. After all, nobody knows what the system should do, so whatever it does is surprising. Then, lack of requirements is the ideal recipe for project failure. So there are many examples of this in the history of programming. Now, the importance of requirements management is also about functional safety and security, because what you want is you want not to deliver the wrong feature, or you want to make sure you didn't miss critical feature. This is why industry standards demand traceability, meaning that every piece of code has to be linked to a specification or a requirement, and every requirement has to be linked to code and to tests that verify that the code actually implements the requirements correctly. In the webinar, we will see practical tools that allows us to fill this important requirement of industry standards. We will in particular see how we can use StrictDoc for capturing requirements and specification, and how we can simply use Doxygen style tags in order to implement the link. The outcome for the adoption of requirements management is clarity, consistency, and compliance with the international standards. In Chapter 5 and webinar 5, we talk about software architectural constraints and how to enforce them. First of all, we introduce why we need them. And the reason is that decomposing a system into systems and subsystems and modules and limiting the way in which these modules can interact with each other, it enables reducing complexity, which is, of course, the enemy number one we have to face in every software project. So this is where the notion of partitioning, layering, and information hiding come from, and this will be explained in the webinar. The thing is even more interesting when functional safety and cybersecurity come into play. There we have notion of independence, isolation, freedom from interference. These are all terms that indicate the fact that we cannot allow unwanted interactions in the system. Because if we have unwanted interaction, what might happen is that failure in one component may cause a failure in another component, which is to be avoided if this brings to the violation of a safety or a security requirement. We will see in the webinar, and you can see in the chapter of the book, that static analysis can be used effectively to check software architectural constraints. In particular, it can detect function call violating architectural constraints, for example, bypassing of an interface. It can spot global variable misuse and also unwanted macro expansions. This is important because the hardware abstraction layer provided by hardware manufacturers typically has all the macros in one header file, but different memory mapper device, they have different criticalities. So you want to make sure that the critical ones are only handled by the modules that are assumed to use them. The benefit from checking software architectural constraints by static analysis is that this allows the early detection of architectural violations, something that is quite difficult to spot otherwise. Imagine a developer not knowing or not remembering a certain architectural constraint, and the developer might, for example, bypass an interface. And you may discover this very late in the project when reworking will be very expensive. If you have these checks routinely performed in continuous integration, any violation will be reported immediately, and you can take action when the cost of doing so is as low as possible. In order to perform static analysis of C and C++ code, we of course need tools, and there are different kinds of tools and different tools in each category, and each one of them is characterized by its own trade-offs. And we will see the different kinds of static analysis that can be implemented, and of course their application, such as the checking of the MISRA coding standards, the detection of important software defects, for example, buffer overflows or concurrency faults. And among the important capabilities we will spend time with is the possibility of integrating them with continuous integration so as to run checks at every commit. An aspect that is very important is the tool configurability. This is especially crucial when you have to apply the MISRA coding standards to legacy code such as open source software. This is a point that we will deal with particular emphasis in that webinar. Again, the goal is to provide immediate, actionable feedback to the development team by the appropriate choice of the tool and its appropriate configuration. In Chapter 7 and Webinar 7, we talk about tool, library, and legacy software qualification. One of the important requirements in functional safety and cybersecurity standards is that tools, libraries, and third-party software have to be qualified, meaning that some sort of argument has to be provided whereby the tools, libraries, and third-party software are fit for purpose, and they respect the safety and security requirements of the project. We will have a guest that will talk in particular about compiler and library qualification. This ensures correct handling of the chosen language subset, and it is, of course, very, very important. We will also pay attention to the important consideration regarding legacy code, in particular open source code. This presents significant challenges. In fact, if not handled properly, this may involve potentially large refactoring, which of course we don't want to do, and we will talk again about MISRA guidelines tailoring. Another important topic is that typically when we adopt legacy code projects, we don't want all of them. We only use part of them, and precisely identifying the part that we use is, of course, essential in order to reduce the qualification effort. The outcome of these steps is having greater confidence in the entire toolchain and code base. The last webinar in the series is based on the last chapter in the book, which ends with 5 key takeaways. First one, start static analysis as early as possible. If you didn't start already, we will show you how to do this effectively. Then manage requirement continuously to make sure that your code is aligned with specs and in order to comply with safety and security coding standards. Enforce architectural constraints to make sure you don't have unwanted interactions in your software, and embrace MISRA guidelines. This is much easier than you might thought, especially in view of the deviation process, which is greatly enhanced by what we call the tailoring of the MISRA guideline, which is the first of the 3 T's, which constitute the 5th takeaway. Tailoring the MISRA guidelines so that they adapt to your internal conventions. Training to make sure that your team is fully aligned and that they know exactly what to do. And tooling, choosing the right tool to implement all the things you need in the proper way. To conclude, if I have to summarize in 2 lines the contents of the book and of the webinar series, static analysis is a key to safety, security, and maintainability, and requirements, architecture, and coding guidelines, they work together in order to give you safety, security, reliability, and compliance. So in this webinar, we announced the forthcoming webinar series. We have 1 webinar for each chapter. We will have renowned guest speaker from the community, and we will have around 1 webinar every month. So stay tuned and you will receive the announcement for the next webinars. And now I am ready to take your questions.
Thank you, Roberto.
Well,
yes, I can hear you. Sorry, we had some issues with the audio. I don't understand. We tried to fix it. I hope you all got what Roberto said properly. I mean, I think it was understandable after all. We'll investigate the issue for next webinars. Sorry about that. So anyway, let's do a little bit of a recap. So as we mentioned at the beginning, the Cyber Resiliency Act, the CRA, becomes fully applicable on December 11, 2027. But the first operational deadline is actually September 11, 2026. So less than a year from now. By that date, we'll just have to comply with vulnerability and incident reporting obligations. That means having the necessary vulnerability monitoring and notification workflows in place, which includes, of course, updated contact points for rapid incident communication, which, for instance, is something that we have in BUGSENG. We have already started asking our customers. And of course, due diligence is something that between now and September is good to set in motion, as Roberto walk us through in various points. So, all right, let's see some questions now. Let me start. I want to start with a popular one. Many of you asked this. So, how do I get this book? Well, actually, some of you may already have it. As we always bring it with us, we bring copies at events, but we realize that's limiting. So it is going to be available online as well very soon. We're just working on the finishing touches with the online platform, but we'll make sure to share a link as soon as we have it. Okay, so for you, Roberto, Paul has a bunch of questions. Let me go through them one by one. First would be, are manufacturers responsible for third-party components? And if so, how do we cover those?
Yes. Yes, can you hear me? Yeah?
Yes.
Okay, so I unmuted successfully. It's always a problem.
Sorry about that.
Yes, manufacturers, well, they have to exercise due diligence on the entire project, including third-party components. So they must verify the integrity of third-party components, both hardware and software, and identify any security risks before they integrate the external component into their products. So manufacturers will have to compile a software bill of materials, an SBOM, and this has to be created and maintained for at least 10 years. And this has to document all the components and their vulnerabilities and how their integration into the product affects security. So security by design is the driving idea. The fact that a component is third party is not an excuse. Of course, the third party supplying the components will have its own obligations. And so it's a shared effort, but manufacturers are ultimately responsible for what they use.
Of course. Still from Paul, are the MISRA coding standards suitable for security critical systems? So not just safety, but security.
Yeah, okay. So this is a frequently asked question, even though it has been clarified now many years ago since the publication of Amendment 1 to MISRA C 2012. Yes, the MISRA coding standard, they address both safety and security. There are MISRA guidelines that are expressly to cover security concerns. And in fact, there is the MISRA working group has published compliance matrices showing that the MISRA C coding standard, but the same thing can be said for MISRA C++, covers completely the CERT-C coding standard, which anyway is no longer maintained. So it's really not an option. Yeah. Okay, so I see another related question. The question is, are there alternatives to the MISRA standards? I guess that I have already addressed one part. So in theory, people approaching security, they may be tempted to say, oh, we need the CERT-C or CERT-C++ coding standard. But as I said, since 2017, these are no longer really maintained and they are not suitable for the work. So the MISRA standards are perfectly adequate, but I can imagine there is another twist to the question. So maybe one wonders should we go all the way to MISRA C, for example, just for the Cyber Resiliency Act and similar regulation, or can we use something simpler? So first of all, there is this thing of tailoring, and you don't have an obligation to adopt the entire MISRA C or MISRA C++. You can choose the rules. Several of the guidelines are advisory, so you are free to choose them or not to choose them depending on the goals of your projects. Another thing on which we will spend considerable time throughout the webinar series is the thing which we call guideline tailoring. So tailoring the MISRA guideline is something that is allowed by the MISRA compliance document, and this typically reduces the effort very much. There is also another possibility, which we regard with favor, which is adoption of a simpler coding standard. For example, the BARC 2018 coding standard. So we wrote a paper a few years ago that was presented at Embedded World, and I think that it is available also on BUGSENG website, about the possible adoption of BARC 2018 as an enabler for an organization to slowly move toward MISRA C and MISRA C++. Okay, so in fact, as I said also in this webinar, one of the important features of BARC is that it has been designed from the beginning to be compatible with MISRA C. So yeah, there are a few alternatives, but typically, if you are scared about adoption of the MISRA coding standard, well, maybe we can convince you that the thing is easier than you might think. Okay, there is another question, and it's actually a very good question. So it says, you did not speak about dynamic analysis. Why that? Well, yes, it's certainly not because dynamic analysis is not important. Dynamic analysis is very important, actually, and it complements static analysis in the overall software verification. So I didn't say much about it because the book is on static analysis, which is what we specialize on, but there are connections. There are several connections between static analysis and dynamic analysis. For example, and that some of them are in scope with respect to the book. So dynamic analysis, basically you run tests, and then there is the thing of traceability of the test to the requirements, and you typically ensure that you have got the traceability correct by using static analysis. So it's static analysis and dynamic analysis working together. Another important thing is that, for example, in modern C++, traditional dynamic analysis is no longer enough. By this, I mean that modern C++ heavily relies on quite complex programming constructs that are fully evaluated at compile time. So by this, I mean that in the final executable, there is no longer any trace of the fact that this code has ever existed. So whenever you have to prove coverage of a test suite, traditional dynamic analysis is no longer enough. So you have to complement it with static analysis to ensure that your tests cover also the part of the code that was fully executed at compile time. Okay, so I think that the questions have been answered.
All right, let's wrap it up. In the next webinar, we'll focus on code quality and software verification. We'll be joined by Nicole Papler, who is CTO and founder at Alectometis. As an independent safety consultant and experienced safety auditor, Nicole will help us understand the role that software verification plays, both in current and future regulatory scenarios. Well, we're still finalizing the date, forgive us for that, but follow us on LinkedIn or subscribe to our updates, and we'll share the details very soon. For what concerns today, if you'd like to rewatch any parts of today's webinar, or I don't know, share it with a colleague, the recording will be available on our YouTube channel, I think sometime next week. Of course, if you have more questions or you just want to continue the conversation, why not? Feel free to message either me or Roberto, yes, directly on LinkedIn. Yeah? Sure.
I'd be glad if you connect, and you can message me by email, by LinkedIn, anyway.
Okay, very good. So thank you very much, everybody, and Roberto, and thank you all for your time and participation. Bye for now, and yes, let's have that great weekend we're all waiting for. Bye, Roberto.
Bye, see you again soon.